This video is going to cover the 7.2 warm-up and the notes from 7.3. So for 7.2 warm-up, it starts by asking you to solve the system using elimination. If we look at number 1, you want to look at to cancel out either the x's or the y's, and you could do this a couple of different ways. But if I just multiplied the bottom by a -3, it's going to cancel out my x's. So I get -3x minus 9y equals -18. And then add that to the 3x minus 2y equals 7. Your 3x and -3x cancel out, and you get -11y equals -11. Divide both sides by that -11, and I get y equals 1. Then I'm going to take that and plug it back in. You can plug it back into either equation. So I'm just going to plug it back into the bottom one. X plus 3 times 1 equals 6. So x plus 3 equals 6, and x would equal 3. So then your answer is going to be in coordinate point form, 3, 1. Number 2 has 1.8x plus 1.2y equals 4, and then 9x plus 6y equals 3. So I'm actually going to start by multiplying the top by 10 to eliminate the decimal. I'd get 18x plus 12y equals 4. And then if I multiply the top by -2, I can cancel out my x's. -18x minus 12y equals -6. When I combine these, the x is both they both cancel out, and so does the y, which means I have a 0 on this side of the equal sign. And then 4 and -6 is -2. Because this is not a true statement, this would be a no solution. And 3 has fractions in both the top and the bottom, so I'm going to start by eliminating the fraction by multiplying by the greatest common factor. So 4 and 8 both go into 8. I'm going to multiply 8 times 3/4. The 4 goes into the 8 2 times. 2 times 3 is 6x. I'm going to multiply that 8 times the y plus 8y, and multiply the 8 times the 1/8, and I get 1. The second equation, again, has fractions, denominator of 4 and 8. So I'm going to multiply everything by 8 again. 8 times 9/4, 8 times 3, and 8 times 3/8. So 4 goes into 8 twice. 2 times 9 is 18x. 8 times 3y, 24y, and the 8 cancels here, and I get 3. So now I'm dealing with these equations. If I multiply the top times -3, I end up with -18x minus 24y equals -3. And this time, all the variables cancel with the 0, and 3 and -3 also cancel, leaving you 0 equals 0. So this is an all real numbers case. Number 4 says a grocer sells oranges for 95 cents each and grapefruits for $1.05 each. You purchased a mix of 16 oranges and grapefruits and paid $15.90. How many of each type of fruit did you sell? So we can identify the two variables. One is oranges and one's grapefruit. So we could do G for grapefruit, O for oranges, or X and Y, whatever you want to do. And the two pieces of information they give you is the price of them and how much you paid overall. So if each orange is 0.95 and each grapefruit is 1.05 and the total amount spent is $15.90, then I can set up my first equation like that. And then if you purchase a mix of 16 oranges and grapefruits, that means O plus G is equal to 16. Now you've got to get rid of your decimals if you want to, so you can multiply everything by 100 here, and I'd get 95O plus 105G equals 1590, and I'm dealing with these two equations. Since we're doing elimination, I'm going to continue this question using elimination, but you could eventually also use substitution as well. So if I want to cancel out the O, let's say, I would multiply everything in the top by -95. I'd get -95O plus -95G, so this becomes a minus, equals 16 times 95, which is 1520, and it's negative 95 times 16. Now I'm going to combine these two. these are going to cancel out. 105 minus 95 is 10G. And then 1590 minus 1520 is 70. Divide both sides by 10. And I get that there are 7 grapefruits. And if I want to know how much fruit there is, I can go back up to O plus G equals 16. Plug in the G for the grapefruits, and I get O equals 9. So how many of each type of fruit did you buy? 9 oranges and 7 grapefruits. Okay, now if you'll open the notes for 7.3, 7.3 is called multivariable linear systems. So the difference between what we're doing today and what we did before was that now we're going to have 3 variables, 3 equations. So we're doing an extra variable here and an extra equation. The first example is just testing a solution. So this says show that the ordered triple 1, 0, 2 is a solution of the system. So just like we started 7.1 with, we would say that this is x, this is y, and this is z this time. And I'm going to take those and plug them into each of these. So x minus 3y plus z equals 3 if x is 1, y is 0, z is 2. Simplify, 1 minus 0 plus 2, 1 plus 2 is 3, and 3 equals 3. So that's the first one. Second one, 2 times 1 plus 0 minus 5 times 2 equals negative 8. And I get 2, the 0 goes away, minus 10, negative 8 equals negative 8. That's the second one. And then the last one, x, which is 1, minus 0, which is y, plus 3 times z, which is 2, equals 7. 0 is gone again. 1 plus 6 equals 7, and 7 equals 7. So again, you won't have a question like this like on your test, but you can. This is basically showing that every answer here is able to be checked by plugging it back into the system. But that solution has to work for all 3 of the equations in the in the system in order for it to be a solution. All right, so the first kind, super easy. These are called triangle system problems. So we solve them using the triangle system method. If you look at these, you'll see one row has 3, one row has 2 variables, and one row only has 1 variable. They're called triangles because the shape of a triangle. So you're going to start bottom up. This is also called back substitution. You're going to plug the one solved variable into the equation with 2 variables and then plug those 2 into the equation with 3 variables. So you're working bottom up. I'm going to take the z, plug it into the equation that has 2 variables. 2y minus 3 equals 7. 2y would equal 10 and y equals 5. And now take z and plug it in here and y and plug it in here. 3x plus 5 plus 2 times 3 equals 8. And I get 3x plus 5 plus 6 equals 8. 3x plus 11 equals 8. 3x would equal negative 3, and x would equal negative 1. So then the solution set here is going to go x, which is negative 1, y, which is 5, and z, which is 3. Okay, example 2. So go ahead and work on it. It says solve the system using back substitution. Again, these are triangle systems, okay? The method is called back substitution. We're going to work our way bottom up. So y plus 2 times 8 equals 6. Y plus 16 equals 6. And y would equal negative 10. And then z into here, y into here, 2x minus a negative 10 becomes plus 10. Plus 5 times 8 equals 24. 2x plus 10 plus 40 equals 24. 2x plus 50 equals 24. 2x would equal negative 26. And x would equal negative 13. So my solution, negative 13, negative 10, and 8. Okay, so now it gets a little bit more complicated. Now we're going to get 3 equations with 3 variables in them each, so we can't use the back substitution. And I know this is a lot of words. I don't expect you to memorize it. Hopefully the process sticks with you. But if you get stuck on the process, then you can come back to this note and help yourself get out of it. So the first step says to pick 2 of the 3 equations and cancel out one of the variables. So we're going to pick any 2 and then work through canceling out one of the variables. You can either cancel out the x's, the y's, or the z's. It doesn't matter. And by doing that, we've now narrowed it down to what we're going to call the new 1 equation. Then we have to use the third equation we didn't use the first time, but you can pair it with either of the other 2. And you have to cancel the same variable as you canceled the first time. So if you canceled x the first time, you've got to cancel x again this time. We're going to call that equation new 2. Then you use new 1 and new 2 to cancel out the second variable and solve for the remaining one just like you would had it been in sections 1 or 2. You're going to plug the first solution back into new 1 or new 2. This is your back substitution because you'll only have 2 variables in those. Once you get the second variable, you're going to plug them both into the original equation to solve for the third variable. So an example will look just like this. Just going to say solve the system. You're going to say 3 equations, 3 variables. So the first thing I'm going to do is actually number these so that when we talk about them, we know which one I'm talking about. The first one we're just going to call equation 1, then 2, then 3. So you want to kind of plan it out. You want to kind of go a couple of steps in advance and see what it is you can do in the future. So the first thing we have to do is cancel out one variable from 2 of these equations. And then from the third equation and another equation, you have to cancel the same variable. So you want to look at your x's, you want to look at your y's, and you want to look at your z's, and you want to see which ones would be the easiest to cancel out more than one time. So if I look just at, let's say, number 1 and 2, I can cancel out the x's by multiplying 2 by negative 2. I can cancel out the y's by multiplying by the top by positive 2. And I can cancel out the z's by canceling out negative 3. So either way, you're going through about the same steps. When I pull in equation 3, if I want to cancel out the same ones, I can pair 3 with 2 and only change one of them for the x. The y's, you'd have to change both. The z's, you'd only have to change one of them. So it honestly doesn't matter too much which ones you're going to pick here. Let's just start with 1 and 2. So 2x plus y plus 3z equals 9, and x minus 2y plus z equals 8. So if my goal is to eliminate, let's say, the y's, because they're already different signs, I can simply multiply my top row by 2. So I'd get 4x plus 2y plus 6z equals 18. And now I'm adding these 2 equations. I'd get 5x, my y's cancel, plus 7z equals 26. And we're going to call this new 1. So because we eliminated the y this time, we have to eliminate the y the next time. And because we didn't use equation 3, we have to use equation 3. So negative 4x plus 3y plus 2z equals negative 4. Now, if I look with the y's in equations 3 and 2, that's where I'd have to change both of them. So I'm not going to pick 2. 3 and 1 is a little bit easier to do. So I'm going to pick 1, 2x plus y plus 3z equals 9. And I need to cancel out the y's. So I'm going to multiply this by negative 3. So multiplying by negative 3 results with negative 6x minus 3y minus 9z equals negative 27. And then I'm going to bring down the original 3. So negative 4x plus 3y plus 2z equals negative 4. Now I'm adding the bottom 2. Negative 10x, these cancel, minus 7z equals negative 31. And this is new 2. So now I'm going to use elimination on new 1 and new 2. 5x plus 7z equals 26. and negative 10x minus 7z equals negative 31. This time we got lucky and the z's will already cancel out without having to change anything. So I'm going to combine these, negative 5x, z's cancel, equals negative 5. Divide both sides by negative 5, and I get x equals 1. So here's my first variable. Now to continue, I'm going to plug this back in, but you can't plug it into one of the initial ones because there'll still be two unknowns. You have to pick to either plug it into new 1 or new 2, and it doesn't matter which one. So let's do new 1. 5 times 1 plus 7z equals 26. 5 plus 7z equals 26. 7z would equal 21, and z would equal 3. Now I've got 2 of my 3 variables. To get the last one, I have to plug it into one of the original equations. And again, it doesn't matter which one, so I'm going to pull 2 because there's less coefficients. X minus 2y plus z equals 8. X is 1. 2y, y's are unknown, plus z, which is 3, equals 8. Negative 2y plus 4 equals 8. Negative 2y equals 4. And y equals negative 2. And then my answer goes in order: x, then y, then z. Okay, last example, it would say the same thing. Solve your system. You again have 3 variables, 3 equations. So we're going to work through it again. Again, try to plan it out ahead of time. I know I have to cancel out 2 things. So this time we can grab 1 and 2 and then do 3 and 1 to cancel out the x's. There's positives and negatives mixed within here, so it doesn't really matter. I'm going to number them 1, 2, and 3. And let's just start with the x's. So I'm going to do 1 and 2, x plus y plus 3z equals 7, and 2x minus 4y plus z equals 7. So to cancel out the x's, I'm going to have to multiply by negative 2. Negative 2x minus 2y minus 6z equals negative 14. And now I'm combining these two. These cancel. Negative 6y minus 5z equals negative 7, and this is new 1. I'm going to repeat that process. This time I have to use 3. So 3x plus 5y minus 4z equals negative 6. And I have to cancel out my x's. So I would look at 1. And this time I'm going to multiply 1 by negative 3. So I'd get negative 3x minus 3y minus 9z equals negative 21. The x's cancel. I get 2y minus 13z equals negative 27. And this is new 2. So now I'm going to pull new 1 and new 2. I'm going to multiply to the second row by positive 3, so I could cancel out the y's. So 6y minus 39z equals negative 81. And then carry down the first equation, 6y minus 5z equals negative 7. Should be negative 6. The y's are going to cancel. Negative 44z equals negative 88. And z equals 2. There's my first variable. I'm going to take that and plug it back into one of the new equations. So I'm actually going to grab the first one. Negative 6y minus 5 times 2 equals negative 7. Negative 6y minus 10 equals negative 7. Negative 6y would equal positive 3. And y would equal negative 3/6 or negative 1/2. And then the last one, I've got to plug it into one of the original ones. So I'm going to drag down the first one, x plus y, which is a negative 1/2, plus 3 times z, which is 2, equals 7. X minus 1/2 plus 6 equals 7. X plus 5 and 1/2, so this becomes 12 halves. So 11 halves equals 7. And x would equal 11 halves subtracted from 7, or 14 halves, which is 3 halves. And then your solution is 3 halves, negative 1/2, and 2. And then remember, with extra time, all of these can be checked by plugging them back into your initial equation. That's the end of the 7-3 notes, so you can use the extra time to work on the 7-3 homework. There is actually one more part to 7-3, but we're going to talk about that tomorrow.